The date is January 30th, 2026. If you have been following the developing celestial anomaly known to the world as 3I Atlas, then you know we have been waiting for the other shoe to drop. Well, it just did, and frankly, the data we are looking at tonight doesn't just challenge our existing models, it effectively breaks them entirely. Let's look closer at the raw data coming in from the Hubble Space Telescope. New images taken just 5 days ago on January 24th have confirmed a structural feature that astronomers had only whispered about until now. We are looking at a high-resolution composite of the interstellar object, and unmistakable in the frame is a sharp, coherent structure, a powerful narrow jet pointing directly toward the Sun. Now, in the context of standard cometary physics, this simply should not be there. Comets, as we fundamentally understand them, are dirty snowballs that heat up as they approach the inner solar system. They outgas, releasing dust and volatiles that form tails. But those tails are dictated by two fundamental forces: solar radiation pressure, which is literally the pressure of sunlight pushing against dust particles, and the solar wind, a stream of charged particles flowing outward from our star. Both of these forces work in tandem to blow cometary material away from the Sun. That is the universal rule. It is a rule that has held for every single comet observed since the dawn of telescopic astronomy. 3I Atlas is breaking that rule. This new jet is an anti-tail in the most extreme sense of the word. It is moving straight into the teeth of the solar wind, fighting upstream against the radiation pressure, and it is winning. The structure extends roughly 400,000 kilometers from the nucleus. To put that in perspective, that is a jet of material stretching the entire distance from the Earth to the Moon, maintaining its cohesion against forces that should be scattering it into a diffuse, invisible cloud. This contradicts what we previously thought about the object's activity mechanisms. When we first saw subtle hints of this in the July 2025 data, there was a lingering hope that it might be a projection effect, a trick of the light caused by our specific viewing angle. That hope is now gone. This is the moment where I should mention that if you want to stay ahead of this rapidly evolving story, you should verify that you are subscribed to the channel. We are tracking this object daily, and as we get closer to the March events, the updates are going to become critical for everyone. Using the Larsen-Cecchinina rotational gradient filter, an advanced image processing technique designed to bring out subtle contrasts in the coma structure, astronomers have revealed that this sunward feature is actually the dominant component of a complex triple jet system. But unlike the other fainter jets, this sunward spike is incredibly tightly collimated. It isn't fanning out like a natural vent, it's a beam. The stability required to maintain a structure like this, which is 10 times longer than it is wide while plunging toward the Sun, implies an intrinsic velocity and a material density that we simply do not see in natural evaporation processes. So, what does this actually mean? It means we have to discard the passive comet hypothesis once and for all. A passive body does not behave this way. If this were simple thermal sublimation, ice turning to gas, the gas would expand isotropically, or at least in a broad cone, before being swept back. What we are seeing here is an outflow that is focused. It suggests a nozzle. It suggests a constrained, directed release of energy or matter that is impervious to the standard environmental pressures of the inner solar system. The brightness of the jet is another puzzle. At this distance, it is inexplicably luminous. If it were made of standard dust, the solar wind should be stripping the smaller, brighter particles away, leaving only heavier, darker grains that would result in a faint, diffuse tail. Instead, the feature remains brilliant and distinct. This suggests the particles within the jet are either incredibly heavy, resistant to radiation pressure, or they are being replenished at a rate that is frankly staggering for an object of this size. Here is the crucial detail that makes this even more unsettling. The jet was already visible in July 2025. This means the phenomenon is persistent. It isn't a momentary outburst or a crustal fracture caused by thermal stress. It is a continuous, stable state of the object. We are watching something that has been on for months, maintaining a precise orientation relative to the Sun despite the object's rapid movement through space. To have a straight sunward-pointing jet from a rotating body requires the source to be effectively locked to the subsolar point. This leads us directly into the orbital dynamics, where the coincidences stop looking like accidents and start looking like geometry. We need to talk about the statistical odds. As we established, the existence of a coherent sunward-pointing jet is already a significant violation of behavior. But if the morphology is baffling, its geometry is statistically terrifying. By tracking the subtle wobble or precession of that sunward jet, astronomers have been able to reconstruct the spin axis of the nucleus. Imagine the object as a spinning top. The axis of that spin isn't pointing randomly into the void. Measurements indicate that the rotation axis of 3I Atlas is aligned with the Sun to within about 7 degrees. This is an extremely unlikely configuration. In the chaotic gallery of interstellar objects, spin axes are distributed randomly. There is no physical law that demands a newcomer to our solar system align its pole with our star. Tidal forces from the Sun are far too weak at these distances to have torqued the object into this alignment. It arrived this way, but the coincidence goes deeper. Not only is the pole pointing at the Sun, but the object's trajectory is also closely aligned with the ecliptic plane, the flat disk where Earth and the other major planets orbit. Most interstellar objects like Oumuamua or 2I Borisov come from random inclinations. 3I Atlas is different. It is sliding in almost perfectly flat. When you combine these two factors, a pole pointing at the Sun and an orbit varying little from the ecliptic, the combined geometry is statistically improbable at better than 1 part in 10,000. So, what does this actually mean? In probability theory, when you see a 1 in 10,000 chance event, the underlying assumption of randomness is often wrong. If the alignment isn't random, it implies a constraint. It implies that the object's orientation is coupled to its trajectory or perhaps coupled to the Sun itself. This contradicts what we previously thought about interstellar debris. Tumbleweed in the wind doesn't orient itself aerodynamically unless it has a fin. 3I Atlas is acting like it has a fin. The specific alignment ensures that one hemisphere is essentially in permanent daylight, while the other is in permanent night. If this were a natural comet, that constant heating could explain steady outgassing, but it wouldn't explain why the jet is stable and narrow. The geometry effectively turns 3I Atlas into a stabilized platform. This brings us to a question I want you to answer in the comments below. At what point does a series of statistical improbabilities stop being a coincidence and start being evidence of something else? We have a physics-defying jet, and now a geometry that defies the odds of random injection. The precision of this alignment becomes even more critical when we look at where 3I Atlas is going next. It isn't just passing through, it is threading a needle. As it recedes from the Sun, it is not heading into empty space. It is on an intercept course with the domain of the King of Planets, and the timing is practically synchronized. The alignment with the ecliptic plane makes a close encounter with a planet much more likely, and sure enough, the calculations show a rendezvous that is shocking in its intimacy. This leads us to the wildest hypothesis currently circulating in astrophysics circles, the Euphemy connection. There is a scenario where 3I Atlas could interact with this region to deploy or deposit material. We are looking at a Hill radius event. If 3I Atlas is a container or a mothership, then this gravitational boundary is the perfect drop zone. The timing is what keeps scientists up at night. If the jet we discussed is a propulsive maneuver, it may have been a course correction to ensure this specific date with Jupiter. Imagine you are skipping a stone across a pond. The speed is 66 km/s. But here is where the physics puts up a stop sign. We have to talk about energy budgets. To turn a 66 km/s flyby into a capture orbit requires a massive change in velocity, or delta V. This is the sheer scale of the challenge. A natural fragmentation imparts a small kick, maybe a few meters per second. We need a kick of 60 plus kilometers per second. There is no known natural mechanism for a small icy body to explode with enough force to halt a fragment dead in its tracks without vaporizing it. To accelerate a fragment backward at 60 km/s requires an energy release comparable to a tactical nuclear detonation focused entirely in one direction. So what does this actually mean? It means if we see a new moon appear around Jupiter after March 17, 2026, we are not looking at nature. Nature doesn't have a braking thruster. Nature doesn't perform orbital insertion burns. If a fragment becomes gravitationally bound, it had to execute a high-energy maneuver. It implies a precisely directed impulse that cancels out the approach speed perfectly. If the jet we saw was actually a braking burn performed early to fine-tune this arrival, then the picture becomes coherent. This connects to the concept of a Bracewell probe or von Neumann probe, theoretical autonomous spacecraft sent to monitor other star systems. A probe doing a flyby might drop a sub-probe. The impossible kick required to leave a calling card at Jupiter is the smoking gun. If 3I Atlas leaves the solar system intact, but Jupiter gains a new satellite, the laws of celestial mechanics tell us that the satellite did not get there by accident. It would have to be placed there. The persistent sunward anti-tail, the improbable geometric alignment, and the upcoming close passage through Jupiter's gravitational domain make 3I Atlas one of the most anomalous interstellar objects ever observed. It makes Oumuamua look like a simple inert rock. We are staring at a potential technological signature. This term is specific. It means data that cannot be generated by the background noise of the universe. The 400,000-kilometer jet pointing upstream is a signature. The 1 in 10,000 alignment is a signature. A captured moon appearing at Jupiter in March would be the final signature. March 2026 offers a rare and potentially decisive test. This is not a drill. We have assets in place, and the encounter will be monitored both by Earth-based telescopes and by NASA's Juno spacecraft. Juno is the trump card here. The spacecraft has been orbiting Jupiter since 2016. NASA has already adjusted observing schedules. Juno won't be close enough to see surface details, but it is perfectly positioned to detect the aftermath. If 3I Atlas dumps energy or fires a thruster, Juno's WAVES instrument and magnetometers might detect the plasma disturbance. If a new moon appears, JunoCam can hunt for it in the weeks following the pass. This contradicts what we previously thought about our readiness. Usually, these objects come and go too fast. This time, we are waiting at the finish line. If nothing happens and 3I Atlas flies by Jupiter without leaving a trace, then we are left with a massive mystery, but a natural one. We will have to rewrite the books on cometary jets. It will be an exotic comet. But if something stays behind, humanity changes. We move from a species guessing about life in the universe to a species studying an artifact left on our doorstep. The impossible kick becomes the proof of engineering. We are weeks away from one of the most significant moments in history. Whether it is a freak of nature or a messenger from the stars, 3I Atlas has already earned its place in the history books. If you enjoyed this deep dive into the unknown, please hit the like button. It helps the algorithm know you want more hard science and less fluff. Until March, keep looking up.